Let's take a look at this example. We're supposed to first find the voltage across the resistor using voltage division law. Okay, so in order to use the voltage division law, we're supposed to find first total impedance of this circuit. In order to find the total impedance, I have to find the impedance of the capacitor. Okay, so I'm going to find the impedance of the capacitor. Z of C is equal 1 over 2 pi Fc. In some books we are going to see X of C. This is basically the same thing. So I have 1 divided by, open parenthesis, and I have 2 pi times the frequency, which is 1 kilohertz, times 1 kilohertz, times capacitance, which is equal 10 nanofarads. Okay, now I'm going to use the calculator. I have 1 divided by, open parenthesis, 2 pi times 1 exponent 3 times 10 exponent 9 negative, because this is nano, equals 15.91 kilo ohms and angle of negative 90 degrees. Don't forget that impedance of the capacitor is supposed to write with angle of negative 90 degrees or simply negative j. You can also write Z of C is equal negative j 15.91 kilo ohms. I prefer to work with the polar form, that's why most of the time I'm going to use the angles. So I found the impedance of the capacitor. If I have impedance of the capacitor, I can find the total impedance of the circuit. Because this is series circuit, I'm supposed to simply add these two impedances together. So I have Z total is equal R1 plus Z of C, where R1 is equal 10 kilo ohms. So I have 10 kilo ohms plus 15.91 kilo ohms and angle of negative 90 degrees. Okay, so this is equal, let me write this down over here, Z total is equal, I'm going to use the calculator. Make sure that your calculator has the complex numbers. So I have 10 exponent 3 plus 15.91 exponent 3 angle of 90 negative. This is equal 18.79 kilo ohms. This is 18.79 kilo ohms and angle of negative 57.84 degrees. Okay, so this is my total impedance in this circuit. Now we're supposed to find the voltage across the resistor. In order to find the voltage across the resistor using voltage division law, we're supposed to write the formula first. So VR is equal voltage source times resistance over Z total. This is equal, voltage source is equal 25 volts RMS. So I'm going to write 25 volts times the resistance of the resistor, which is equal 10 kilo ohms, over 18.79 kilo ohms and angle of negative 57.84 degrees. Close the parenthesis, this is equal. Now we are going to use the calculator. So we have 25 volts, 25 Okay, I have 25 over here. 25 times, open parenthesis, 10 exponent 3 divided by 18.79 exponent 3 and angle of 57.84 negative, close parenthesis. This is equal 13.3 volts and angle of 57.84 degrees. Okay, so this is the voltage across the resistor, and we found this voltage using voltage division law. Next, we're supposed to find the voltage across the capacitor using Kirchhoff voltage law. In order to do so, we're supposed to simply write the KVL for the circuit. So we have to write that voltage source is the sum of the voltage drops across each component. So I simply write that voltage source is equal VR plus VC. So if you want to find VC, okay, so VC is going to be equal voltage source minus VR. This is equal voltage source is equal 25 volts minus 13 VR, okay, 13.3 volts and angle of 57.84 degrees. So my VC is equal 25 minus 13.3 and angle of 57.84 is equal 21.16 volts. 21.16 volts and angle of negative 32.14 degrees. Okay, so this is voltage across the capacitor. Next, we're supposed to find the current which goes through the resistor, okay? But keep in mind that this is series circuit, so the current which will flow in this circuit, I mean the total current, is going to be equal to the current which goes through the resistor and is going to be equal to the current which goes through the capacitor. So I can simply write that my IR is nothing else just IR1, which is equal to IC1, and this is nothing else just I total. So if I want to find the current in my circuit, I'm going to simply divide voltage source over the total impedance. Okay, because we are dealing with the RMS voltage, my current is going to be also RMS. My problem doesn't specify that the current has to be peak or peak to peak. That's why I'm going to find the RMS value. So voltage source is given, is 25 volts RMS. We found Z total 18.79 kilo ohms, an angle of negative 57.84 degrees. So that's why I'm going to write that my I total is equal 25 volts divided by 18.79 kilo ohms and angle of negative 57.84 degrees. Okay. Now we're going to use the calculator, and we have 25 divided by 18.79 exponent 3 and angle of 57.84 84 negative. This is equal 1.33 milliamps and angle of 57.84 degrees. So let me write this down. So if IR is equal 1.33 milliamps and angle of 57.84 degrees. Okay, so this is the current which will flow through the resistor and through the capacitor, because this is the series circuit. Okay, so this is my total current, and current will go through the resistor and current will go through the capacitor. Next, we're supposed to redraw the circuit using the equivalent impedance in place of resistance and capacitor. That's why I'm going to draw simply voltage source. It's my voltage source, and it has value of 25 volts RMS and frequency of 1 kilohertz. And now we have over here impedance. This is my Z total. Okay. And my Z total is equal 18.79 coulombs and angle of negative 57.84 degrees. So now I can say that the problem is solved.